All right, learning target 14 again, we're just putting things into real world scenarios. So all the stuff we've been doing, we're just going to put it into a word problem, if you will. Again, on the test, or actually on the quiz, just a bonus, same thing for on the test. So you don't have to freak out that you won't know this by Monday. All right, so the first example. It says if the equilibrium point is y equals 0, then y equals -5 times the cosine of pi over 6t models a buoy bobbing up and down in the water. All right, if you think about that motion, it's going to make a wave-like motion, right? It's going to go up and then bob back down and go up. So we can model that using a cosine curve. Okay, so we're just going to be answering some questions. A says, describe the location of the buoy when t equals 0. So all we have to do is substitute 0 into the equation. It's not like we're doing anything fancy. So y equals -5 times the cosine. Well, pi over 6 times 0 is 0, right? When you use your calculator to figure this out, this is the first time so far in this unit that you would have had to use sine, cosine buttons in your calculator, so you now have to make sure it's in radian mode. If you're going to do cosine of 0, you're going to make sure everything's radians, etc. If you do that, the cosine of 0 is 1. You can get that from the unit circle as well. So what's -5 times 1? -5. So we are -5 units from equilibrium. It just says describe the location, so that's what I'm saying. Questions about what happened on A? Honestly, all you have to do is substitute a number into the equation, right? On B, what is the maximum height of the buoy? We're talking about maximum heights or maximum anything on a sine or cosine curve. What do we need to know to figure that out? So I was going to say the maximum of just any other cosine curve, not just this one. How do we do that when we're graphing? Amplitude, right? We look first if there's a vertical shift, and there's not on this one. But there's a vertical shift, and then we would use the amplitude to figure out what the maximum minimum heights would be. So in this case, what is the amplitude? 5, right? We're doing maximum height, then the maximum height is 5 units above equilibrium. So you can figure that out from the amplitude. If there was a vertical shift, then you take the vertical shift and add 5 to that, right? Just like when you're graphing. This is not new. And C just says find the location of the buoy at t equals 7. So the same thing, we're just substituting a number into an equation they've already given to you. You guys could all do that without me standing up here and telling you. Again, just make sure that your calculator is in radian mode. So you'll have 7 times pi over 6 is 7 pi over 6, so cosine of 7 pi over 6. So I got -5. That ends up being -0.87. So I got 4.33 units from equilibrium. And I just used my calculator. Make sure it's in radian mode. Any questions about that example? Again, most of which is substituting stuff in, right? All right. Next example. A certain person's blood pressure oscillates between 140 and 80. If the heart beats once every second, write a sine function that models the person's blood pressure. So we're going to write an equation just like we would for anything else. The first thing we're going to look for is a vertical shift. The blood pressure is oscillating between 140 and 80. So there has to be a vertical shift, because if not, it would be centered around 0, and this is not. So there has to be a vertical shift. The vertical shift is whatever that middle number is between 140 and 80. So how can I find the middle number between two numbers? Just take an average, right? So that's what we're going to do. So 140 plus 80 divided by 2, and I got 110. Does that make sense? Okay. The the second thing we need to figure out is the amplitude then. Well, the amplitude tells you how to get the max and the min from 110, right? So it's like 110 plus what is 140, or 110 minus what is 80. Should be the same number. So what's the amplitude? 30. Right? 110 plus 30 is 140. 110 minus 30 is 80. Well, the amplitude in the equation is just going to be positive. But yes, plus or minus to get both of those numbers. Questions so far? All right, need to figure out the period. Remember, the period is just how often something repeats. So it says, how often does the heart beat? It says once every second in the problem. So the period is 1 second. If we're going to write an equation, we'll need to know k then, right? So we'll say 1 second equals 2 pi over k. So k equals 2 pi. Does that make sense? And then there's no indication in this question there's any phase shift. It doesn't say anything weird or funky about something being shifted or anything, so we can't assume that there is. So there's no phase shift as far as I'm concerned. In the next question, we'll see a situation where there might be a phase shift. But so no phase shift. And so we're just going to write this in equation form. It says it's a sine function. So we have y equals, what's the first thing I should do? 30 sine 2 pi theta. There's no phase shift, so I can close parentheses. Plus 110. Make sure the plus 110 is not in parentheses. If you put it in parentheses, that means it's a phase shift, and it's not, it's a vertical shift. So that's the answer. Questions about that? Okay. The last example is a little bit longer, but it's really just a bunch of algebra, so it's not that bad. It says the average monthly temperatures for the city of Seattle, Washington are given below. And we can see from January to December that the temperatures go from 41 all the way up to 66, and then they start decreasing again, right? A says to find the amplitude, and B says to find the vertical shift. In my opinion, it's easier to figure out the vertical shift and then the amplitude. So I'm going to do part B first, and then do part A second. All right? So we need to figure out the maximum and minimum temperature so we can find that middle again. So the maximum temperature was 66. The minimum was 41. Right? So to find the vertical shift, we just average those. And I got 53.5. So now that I have the vertical shift, I can figure out the amplitude from there. So 53.5 plus what will give you 66, or minus what will give you 41. And I got 12.5. Is it making sense where I'm getting these numbers from? All right. C says, what is the period for the monthly temperatures? Well, this is from January to December, and then it's going to repeat again, and it's going to repeat again, right? So what's the period? 12 months. And well, you can use that to find k, because we're going to have to write an equation in a second. So this is the actual period, and then 12 equals 2 pi over k. 12k equals 2 pi. So 2 pi over 12 reduces down to pi over 6. We're going to need that in a second. But the period itself is actually 12 months. Any questions on A, B, or C? Okay. Part D says to write a function that models the monthly temperatures using t equals 1 to represent January. Because it's not t equals 0, that indicates there's a phase shift, because we're not starting at the y-axis. Does that make sense? Now, that's the tricky part, because we don't really know what the phase shift is so much. Okay? We can base off the period. So here's what we're going to do. to think about a lot of things. It doesn't tell us if it's a sine or cosine. So I need to think about the shape. Okay? If you look at the temperatures, and you started graphing the temperatures, all right? We start at 41, and we go up to 44. We go up, and we go all up to 66. And then we start going back down in one period. So is that sine or cosine? Cosine, right? Sine would go up and then down and back up, right? Cosine normally goes all the way down and then back up. Since it's upside down, what does that mean? Right, so it means we're going to do cosine, and we're going to put a negative in the front to indicate you flipped it over. Does that make sense? Why I say it's cosine and why it's negative. Okay. So here's what we got for D down here. So I need some space. We know right now we have y equals negative 12 and a half, because that's the amplitude, times cosine, we just talked about y, pi over 6, that's what k was, times t, or times theta. They're using t in this question, so I'm using t, but you can put theta, it's not wrong. We don't know what the phase shift is, though. We know it's going to start at t equals 1 instead of t equals 0, but we don't know what the phase shift is. And then we have plus 53.5. I have a whole list of points, though. Like it tells me January is t equals 1, and I know a temperature for January. So in order to solve for C, we're going to put in a t value and a y value, and we're going to do an algebra problem to figure out what C is. Does that make sense? So since January is t equals 1, that'll be easy, and we have 41 degrees. So I've got 41 equals pi over 6 times 1 is just pi over 6. So I'm just plugging in the point 141. That's all I'm doing. Does that make sense? Okay, then we're going to do some algebra. So what's the first thing I need to do? Subtract 53.5. If I subtract 53.5, I get negative 12 and a half. Look how well that works out. What's the next step I need to do? Divide by negative 12 and a half. So we get 1 equals cosine pi over 6 minus c. I don't want to distribute the cosine because that just means I have two cosines, and that's not good news. I mean, I guess you could do cosine of pi over 6 and then go from there. You could, though, in one step, just use inverses. Okay, so you have two options. Distribute, which I think takes longer, or use inverses. So you take the inverse cosine of everything. So by doing that, you take the inverse cosine of 1, which is 0, and then you're just left with pi over 6 minus c. Because the inverse cosine of cosine cancels that out. So then to solve the equation, you just add c to each side. Again, you also could have done 1 equals cosine of pi over 6 minus the cosine of c. The cosine of pi over 6 is an actual number, so you could have gotten that and subtracted that from 1, and then divided by negative 1, and then taken the inverse. That's more sense. So you could have done it that way. Yes. We don't know. We could have, let's see here, 1 equals c over, yes, that would have worked as well. So algebra, or you could have used phase shift equals c over k. The phase shift, since we're not starting at 0, would have been 1 unit, so 1 equals c over pi over 6. You could do it that way too. I like doing algebra, though. I don't think things easy. I'm a math teacher. All right, question. Okay, so now we have D. I'm not going to waste time with E and F, but E and F just say, according to your model, because now we know what this is, we could put pi over 6 right here in the equation. Right, now I know the entire equation. E just says, what's the average monthly temperature in February? Well, that's where T equals 2. So you just stick 2 in for T and figure it all out. And it says, how does that compare to the actual average? So you just compare the two numbers. And F is the same thing, just for October. So you put T equals 10 into the equation. and then compare. I will not waste your time with that though. Questions about these examples?